Hello students, welcome to chapter 10 Vector Algebra. So students, today I continue our new topic that is called scalar product, either dot product between two vectors. Either that is also called, it is an inner product. So consider here our two vectors, one of the vector A and one of the vector B. Between that, here two direction O to A and O to B, and that between some making angle theta. So you have to assume A1, A2, A3 and B1, B2, B3 belongs to R cube. Yes, two vectors. Now I going to scalar product, which is A dot B. Very easy. A1, A2, A3 dot B1, B2, B3. So this dot product means nothing. This first element multiple with the first scalar elements A1, B1 plus A2, B2 plus A3, B3. And this answer is always belongs to R. Yes, this always belongs to R. That's called our scalar products. Now I going to that some properties. Yes, properties of related your dot product. First, A dot A is always modulus A whole square, which is non-zero. Second property, A dot B, you also read as B dot A, because A dot B and B dot A both answer are equal there every times in dot product. Now third, some lambda constant A with dot B, either A with dot lambda B, either lambda of A dot B always are same for every lambda belongs to R. And fourth property and last property, it is that A dot some vector B plus C addition. So you can show A dot B plus A dot C. Yes, A dot B with A dot C. Now students, second property we going, angle between that two vectors. Yes, angle between A and B is theta. So we can show in this form cap A, cap B with the theta, upper side capped, and that is the property. Very easy. Cos theta A dot B upon modulus A modulus B, and that is the formula for angle between two vectors. And one more note, if this is a property for MCQ level, if A dot B we can cover 0, if you write down here 0, then your cos theta 0 by magnitude A, magnitude B, which is 0. It means theta become cos inverse 0, they have to pi by 2. It means the two vectors are perpendicular to each other, 90 degree making. Then sure, angle between them 90, then dot product is 0. So the conclusion is, if A dot B 0, then necessary A is perpendicular to B. And that you by heart for MCQ level. Whenever you proving 90 degree, either different word, orthogonal also. Students, it is called orthogonal between A and B. Then necessary we will prove A dot B is equal to 0. Now continue students, we going ahead. Point number 3. Yes, now projection coming. Projection of A on B. Very easy. New point. Projection A on B. Projection of A on B. Very easy. First of all, I write down formula. Projection of A on B, you can show A dot B by magnitude B. And properties level, there are the 4 different drawing given. First drawing for theta, your 0 to 90 degree. Between S, angle between two vectors is 90, and the drawing is that. Consider here your vector, first of all A to B, AB vector. And that is your perpendicular 90 degree to C, that is your B vector. So definitely this angle is a theta between what? Yes, between 0 to 90 degree. And here this is your projection, students. That you consider your vector is in this way. There are 4 quadrants. This is 0 to 90 degree. Now I go to 90 to more. Second, 90 degree to 180 degree. It means this drawing I plot these sides. Consider that's your coordinate, y-axis, x-axis. I go to now this sides. My drawing is covered to that way. So here I am making the drawing. These are, and that is your degree for theta 90 to 180, and that's your cover A to B. Students, here this vector. Second, here B to C, that one. And you can write down this theta exactly here A, here the B, and that's your P, projection P. And that's your simple consider, students, your second drawing. Now same as I going to drawing number 3. Yes. Third drawing is a 180 to 270. That is called in this way. Just we can draw here in this part, and your degree measure to that, these to that, this sides, and according to drawing, students, you can plot that here A, B and C. Here your projection P, that is your A, that is your B, and here with 90 degree. And fourth drawing to cover the 270 to 360 degree, and that also given students moving to up to towards or more than 270 in this way. Your drawing to cover in this parts. Yes, that is the C to 180 degree given. It is here plotted. That degree given here. That is the theta. Here that is the theta, and here that is the theta. Up to that. So here also you can write down, students, here C, here A, and here B. Very easy. That's your P projections. Here A and here B. So projection A on B in a different way, but you can cover, students, this only formula, A dot B by magnitude of A. Yes. Now I going ahead our questions. Example continue, students. Example number 13. Very easy numerical and very simple. So slowly I going, students, in the easy way. Yes, define angle between vector A and B for 2 vectors. Example 13. If modulus A 1, modulus B is 2, and A dot B is 1, then find our angle between A and B. Find angle between A and B. Very easy. Formula you know already. Angle between 2 vectors. Students, cos of between that A and B, which is A dot B by magnitude A, magnitude B. A dot B, I have 1, here 1 and here 2. That is only half. And cos of angle between AB. So what is the angle between A and B? Very easy. Which is cos inverse half. And now when, students, cos is half? Yes, 60 degree. Pi by 3. Next, example 14. Which is also same property wise we going ahead. Yes, again asking angle between two vectors is theta. For a vector A, I, J minus K, and B, which is I minus J plus K, then find angle between A and B, theta. Yes, clearly given angle between two vectors. One more time check. 1 1 minus 1 and 1 minus 1 and 1. Yes, easy students. First of all, you can write down A vector 1 1 minus 1, B 1 minus 1 1, and you just say both of the magnitude. So magnitude of A root 3, magnitude of B root 3, and both dot product. Students, simple, you know dot product between that A dot B, 1 1 minus 1 dot 1 minus 1 1. So 1 1s are minus 1 minus 1, it is minus 1. So angle between both vector A and B, which is A dot B by magnitude A, magnitude B. But dot product also known, students, minus 1 and root 3 root 3. So what is the cos theta? Theta become cos inverse minus 1 by 3. Either you can write down pi minus cos inverse 1 by 3. Here students, very easily be going. Now 15. Yes, 15 is an IMP for exam level. Question heading 15th one. Yes, vector A and vector B given, then prove that A plus B and A minus B are orthogonal to each other. I mean perpendicular to each other. Yes, if A vector I have phi I minus j minus 3k, and B I have I plus 3j minus 5k, then show that vector A plus B and vector A minus B are perpendicular to each other. Either you can write down it is orthogonal to each other. Yes, orthogonal also word, students, here correct for perpendicular. So here given according to A, phi minus 1 minus 3. Next B, students, 1 3 minus 5. You just define first A plus B. So now I calculate A plus B. So 5 minus 1 minus 3 plus 1 3 minus 5, and make them additions. So students, here 6, next 2, next minus 8. Also you can try A minus B, 5 minus 1 minus 3 minus 1 3 minus 5. So that are, students, between subtractions. 5 minus 1 4, minus 1 minus 3 minus 4, and minus 3 plus 5, minus 3 plus 5, which is 2. Now what should prove? I will prove perpendicular to each other, orthogonal to each other, means dot product. So I will take A plus B dot A minus B. Anyhow I will prove here, students, 0. So 6 2 minus 8 dot 4 minus 4 2. So 6 4 the 24, 4 2 the 8, and 8 2 the 16. 24 minus 24, 0. It means, students, here our property done, dot product 0. So A plus B is perpendicular to A minus B, and that here, students, here this orthogonal, either perpendicular. Done. Now continue our example 16. In the 16th one, question is available. A and B vector given, and find out projection of A on B. Yes, vector A 2i plus 3j plus 2k, and second vector b, they have to I plus 2j plus k. Again check 2 3 2 and 1 2 1. Yes, find projection of A on B. So very easy. First of all, A vector clear, 2 3 2, and B vector 1 2 1, 1 2 1, and define first. Yes, A dot B. We needed 2 3 2 dot 1 2 1 and apply dot product. So 2 1s are 2, 3 2s are 6, 2 1s are 2, total 10. And you also declare magnitude of B 1 2 1, which have to 1 4 1, which is root 6. So projection of A on B, which is called PROJ projection, A on B, A dot B by magnitude B. Simple formula apply, and A dot B I have 10, and that is root 6. Can we write down root 6 up and root 6 down, conjugate by 6, and that is your answer, students. 5 3s and 2s, 5 by 3 root 6. Yes, 5 3 2s and 5 2s. That's your answer, students. It's very easy projections. Now example 17. Continue 17th example. So question is that, yes, vector A, vector B, magnitude given, dot given, and asking that magnitude. So for two vector A and B, modulus of A 2, modulus of B 3, and A dot B is 4, then find A minus B, the magnitude. So does magnitude, if you asking, then you will first cover magnitude whole square. Yes. So first of all, we start here in modulus A minus B whole square. You know that whole square magnitude. Property number 1 for scalar, A minus B dot A minus B, and now apply A dot A minus B, continue B dot A minus B, and now apply simple 1 by 1 our dot product. So students, here A dot A dot B, next B dot A plus B dot B, that is 2 times that one magnitude A whole square, 2 times A dot B and magnitude B square. So just now wait, all data you know that. What is magnitude of A? 2 square, A dot B 4, and B magnitude 3 square according to given. So students, here 2 square 4, 4 to 8, 3 square 9. It will be 4 plus 1, which is 5. But which value is this? It is magnitude of A minus B. You write down here same as a. So my value, magnitude of A minus B is a root 5. And that, students, very simple and easily it done here. Now continue our question number 18. Yes, 18 also, students, same as a unit vector A given and asking modulus of x. So our question is 18th one. If A is unit vector and x minus A dot x plus A is equal to 8, then find out modulus of x. Students, clearly given here A is a unit vector, it means that magnitude is 1. So if A vector is unit vector, that's why magnitude A is 1. Now I will start our question. X minus A dot x plus A is equal to 8, and apply on it both of the respectively dot product. So x dot x plus A minus A dot x plus A is equal to 8. So students, can we write down here x dot x dot A, next A dot x and A dot A. Very easy, that is cancelled because both of the same. And here magnitude x square, magnitude A square 8. But what is the modulus x square? Target. And modulus A, it is 1 according to unit vector. So ax whole square 1 whole square 8. Mention here unit vector, either given. So x whole square 8 plus 1 9. So what is the x magnitude? Which is only and only, students, 3 here. And here our example 18 is also, students, easily and happily done. Now continue, students, we go in example 19. 19 and 20 both of the students IMP for board exams. Example number 19 and 20 both of the IMP in board exam level. Question is, for any two vectors A and B, prove that for any two vectors A and B, prove that it is a dot product A dot B is less than magnitude A, magnitude B. It is called our squares identity. Yes, this statement is called squares identity, students. Very easy. For any means we have to here two cases. One of the case 1, I will true first if A 0 vector or B is 0. Definitely A dot B is 0. Magnitude A, magnitude B 0. So A dot B is less than modulus A, modulus B is true. Now case 2. In the case 2, now I checking to non-zero A and B. So here also same, if A vector non-zero and B vector or B is also non-zero. So students, we know that as a property for range of cos theta minus 1 to 1. But I will check in magnitude, means only take positive sides. That's why here I will take here cos A dot B magnitude A, magnitude B is less than or equal to 1. So what is the positive case only? This case not we cover, only positive case cover to magnitude A, magnitude B less than 1 because A dot B positive. Magnitude no, that's why. So what's your cover answer? Magnitude A dot B is less than or equal to magnitude A, magnitude B, and that's your students proving for this answer. It means both of the correct in any situations. Now example number 20 is also depend on our example number 19. Yes, to prove for any two vectors now 20 examples. Question continue. For any two vectors A and B, for any two vectors A and B. Prove that A plus B is less than magnitude A, magnitude B. So it is here also we can cover, and this is called your triangle inequality. Yes, this is your triangle inequality. A property, I going to case 1. Same as I explained. If A 0 or B 0. So students, what's the A plus B magnitude? Definitely 0. Magnitude A, magnitude B also 0. So A plus B is less than modulus A, modulus B is true. First case happily done. Now I go to case 2. Simple. Now non-zero. If A never 0 or B never 0. So now I start my main process, A plus B magnitude in whole square. A plus B magnitude whole square, which have to known A plus B dot A plus B according to our property. Now dot product we will do A dot A dot B, B dot A, B dot B. These are the like terms, 2 times. And here magnitude A whole square 2 times A dot B and magnitude B whole square. Now students, this property I will use by this quartz inequality. Yes. So before apply, you can write down one more times, it is modulus, because I will cover in positive way only. In this case, A dot B modulus is your less than or equal to modulus A modulus B. Here we will write down less than, apply there modulus A modulus B, that is the square, and here write down according to property A dot B is less than modulus A modulus B, that one. And now students, it is your perfect square. Here same you write down in each case A plus B whole square. So our data is A plus B whole square is a modulus A and modulus B, that square. And now students, you will take simple both sides square root. So modulus A plus B is less than or equal to modulus A plus modulus B. And here students, our next property also, example number 20 is simple and easily students here done. Now this 19 and 20, both of you, I again repeat, it is most IMP numerical. Yes students, up to that example 20, I will stop this part and further explanation students same as I explain in the next part. Bye bye.